Lesson 29 is about ratios, and a ratio is a comparison of two different quantities or two different numbers. And when you are doing a ratio, you need to just look at the problem and see if it's girls to boys, you find the number of girls and you put it over the number of boys, or boys to girls, you do it vice versa. And we'll see some problems like that in just a little bit. Number 1 says 1,000 pounds of grain were packaged in 5-pound bags. How many bags were there? So this is an equal groups problem. So we have the number of bags times how many pounds are in each bag, which is 5, and that equals 1,000. So our question is, what number times 5 gives us 1,000? And it's 200 bags. 200 times 5, 2 times 5 is 10, and then you add 2 zeros at the end, you get 1,000. The minute hand of a clock changes position by 30 degrees in 5 minutes. What fraction of a full 360-degree turn is this? Well, all we need to do is say that it's 30 degrees out of 360 degrees. And I can divide both of those by 30. 30 divided by 30 is 1. 360 divided by 30 is 12. So it's 1/12 of a full turn, which makes sense because there are 12 numbers on the clock, and each number stands for 5 minutes. Compute an 18% gratuity on $3,000 banquet fee. So 18% is going to be 10% plus 8 times 1%. And it's easiest when you're calculating percents to deal with 10, 1, and 100%. To find 10%, we move the decimal place 1 place to the left, and to find 1%, we move the decimal place 2 places to the left. So 10% of 3,000 if I have the decimal point here, I move it over 1 place, so it's going to be $300. And then 1% of 3,000, if the decimal point is here, I move it 2 places to the left, and it's $30. So 8% is 8 times 1%, which is 8 times 30, which is $240, which is reasonable. It should be close to 10%, but less than 10%. So then the total gratuity would be 300 plus 240, which is $540. If the base and height of a triangle are the lengths of 2 sides of the triangle, then the triangle is a right triangle. And what they're saying is, if this is the situation, and you can use this length here, let's say 8, and this length here, let's say 6, and we call these the base and the height are always perpendicular to each other, so it has to be a right triangle. It's not true in every kind of triangle. For instance, if I have an obtuse triangle, the height actually comes right here, and that would not be one of the sides of the triangles. Or if I have an acute triangle, that wasn't a very good acute triangle. Let me try again. The base and the height, the line that's perpendicular here. Actually, this one would be outside the triangle. That's what I was missing. So it goes from here to here. So essentially it's the right triangle where the base and the height can be used as sides of the triangles. Val planted 36 pumpkin seeds in the community garden. In 2 weeks, 27 of the seeds had germinated. What percent of the seeds had germinated? So to figure out percent, we can start with a fraction. So we take the number that germinated, 27, and divide it by the number of total seeds there were, 36. 27 and 36 can both be divided by 9. 27 divided by 9 is 3. 36 divided by 9 is 4. And then the fraction 3/4 is the percent, 75%. To simplify, you could do this 2 different ways. You could use the law of exponents. So we have things of the same base being multiplied, which means that we're going to add the exponents. So this would be 5 to the 2 plus 1 plus 0 power. 2 plus 1 is 3 plus 0 is still 3. So we have 5 to the third. And 5 to the third is 5 times 5 is 25. Times 5 is 125. The other way that you could do it would be to actually figure out what each individual thing is. So 5 squared is 25. 5 to the first is 5. And 5 to the 0, well, anything to the 0 power is 1. So 25 times 5 is 125 times 1 is 125. In number 7, we're subtracting things of the same exponent. There isn't an easy law to go along with that. So we're just going to figure out what each one is and then subtract from there. So 10 squared, 10 times 10 is 100. 10 to the first is 10. And then remember, anything to the 0 power is 1. So I have 100 minus 10 is 90, and 90 minus 1 is 89. In number 8, they're asking us to simplify, which means use exponents. So I have x, 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 that's x to the third, and w, w is w squared. This just means that these two things are being multiplied together. So without the parentheses, it could be written just the same. I would have 2 x's, so x squared, and 2 y's, so y squared. In number 10, what we need to do is first convert them into improper fractions, and we do that by taking the whole number, 5 in this case, and multiplying it by the denominator, 25. So 5 times 5 is 25. And then we add it to the numerator. So we have 26 fifths. And then this one, we take 2 times 2 is 4, plus 1 is 5. So you have 5 halves. And that makes sense, because if you had 5 halves, that would be 2 1/2. And then we're going to multiply straight across. Well, I can eliminate some things so my multiplication's easier. Because I have a 5 and a 5 diagonal from each other, I can divide those out right away. So this would be 1, and 5 divided by 5 here is 1. And then I can divide 2 by 2 and 26 by 2. 2 divided by 2 is 1. 26 divided by 2 is 13. So then I end up with 13 times 1 is 13. Over 1, it's still just 13. Number 11, we have order of operations mixed together with some fractions work. So we need to remember, please excuse my dear Aunt Sally, which means we will do the division before we do the addition. So we take care of those two things first, and when we divide by a fraction, we multiply by its reciprocal. So we have 1/2 plus 2/3, and then times the reciprocal of 3/4 is 4/3. And now I'm going to do that multiplication. When I multiply fractions, I multiply straight across. So I have 1/2 still, because I haven't done anything with that. And then 2/3 times 4/3 is 4 times 2 is 8, and 3 times 3 is 9. And now I have to add 1/2 and 8/9. And to do that, I need to have a common denominator. So I'm going to find a multiple of 2 and 9 that is common, and that's going to be 18. So I have 1/2 written as something over 18. Well, to go from 2 to 18, I multiply by 9. Whatever I do to the bottom, I do to the top. 1 times 9 is 9. And then I have 8 over 9 written as something over 18. To go from 9 to 18, I multiply by 2. Anything I do to the bottom, I do to the top. 8 times 2 is 16. So now my problem becomes 1/2 is written instead as 9 over 18. And then plus 16 over 18 in place of 8/9. So 9 plus 16 is 25 over 18. Which then leaves us with 18/18 and 7/18. So 1 and 7/18. So this is all for number 11. In number 12, we have a fraction with addition on top. And when we see operations within a fraction, what we do is we treat it like there's parentheses on the around the operation. So we're going to do this part first. So 1.35 plus 0.07. When we add decimals, we line up the decimals. So 5 plus 7 is 12. 3 plus 1 is 4. Bring the decimal down. And then 1 plus 0 is 1. So we end up with 1.42 on the top and 0.2 on the bottom. Then we're going to divide by a decimal. And what that looks like is 1.42 divided by 0.2. And when we have the divisor as a decimal, we need to move the decimal point so until it's not a decimal anymore. So we need to move it one place to the right. We move this one place to the right to match. And so our new problem becomes 2 on the outside and then 14.2 on the inside. Now the division's just regular. The only thing is you put the decimal point up at the beginning so you know where it is. We ask ourselves, how many times does 2 go into 1? It can't. So then we say, how many times does 2 go into 14? It goes in 7 times. 7 times 2 is 14. 14 minus 14 is 0. Bring the 2 down. How many times does 2 go into 2? It goes in once. And 1 times 2 is 2. 2 minus 2 is 0. So our answer then is 7.1. Number 13, the first thing that we need to do is parentheses, because that's what the P and please excuse my dear Aunt Sally stands for. So we're going to add 101 plus 10.1. 101 plus, the decimal point for this one would be here since it's not shown, 10.1, and then I'll put a placeholder 0. And we're adding them, so 0 plus 1 is 1, 1 plus 0 is 1, bring the decimal point down, 0 plus 1 is 1, and 1 plus 0 is 1. So now the problem becomes 0.01 times 111.1, and when we multiply things, we ignore that there's decimals and then we count them up in the end. So what this is going to look like is 1,111. So I'm ignoring that there's a decimal point. And then times, ignoring that there's a decimal point, the only non-zero number is 1. So basically it's going to be 1,111. And then I go back and I ignored 1, 2, 3 decimals, so I move it 1, 2, 3 decimals over. So that gives me 1.111 as my final answer. Cruz filled his car with 10.2 gallons of gas at $2.89 per gallon. If he fills his car with about this much gas at this price once a week, estimate how much he will have spent on gas after 4 weeks. So if I'm going to estimate, I'm going to call this 10 gallons, and I'm going to call this $2.90. I could call it 3 as well. $2.90 is going to give me a better estimate though. So to figure out how much money Cruz is spending on gas, I take the number of gallons and I multiply it by the cost per gallon. So 10 gallons times $2.90 per gallon, and that gives me $29 each week. And then I would round that to 30. And then I'd take $30 per week and then times 4 weeks. 30 times 4 would be $120. So again, if you would have rounded this to 30, it would have been the same thing. Rectangles ABCD and MNOP are similar. What scale factor is used to dilate rectangle ABCD to rectangle MNOP? Round your answer to the nearest thousandth. So they're asking, how do I go from this rectangle here to this rectangle here? What do I multiply the lengths by to go from 2.4 to 6.25? So to figure that out, I can take 6.25 and divide it by 2.4. So, since I'm dividing by a decimal, I need to move it so that it's no longer a decimal. And however many places I move that one, I need to move the inside one. So now my problem becomes 24 on the outside, and then 625, or 62.5 on the inside. So carry the decimal point up. How many times does 24 go into 6? It can't. So then how many times does 24 go into 62? Well, 24 and 24 is 48, and another 24 would be 72, so I can only fit 2. 2 times 24 is 48. (62 minus 48 is 14). bring the 5 down. So now I have 145. 24 goes into 145 6 times, I believe, because 72 and 72 would be 144. 6 times 24 would be 4. 14. So then we have 1. So then I'd put an imaginary 0 there, and I'd have 10. 24 can't go into 10, so I put a 0 up here. Put another 0 here. How many times does 24 go into 100? It goes into 100 about 4 times. 4 times 24 will be 96 cents. And it told us to carry it out to the thousandths, so I have tenths, hundreds, thousandths. So 2.604. What this means is if I take the side lengths of rectangle ABCD, so in this case the one that we know is 2.4, and I would multiply it by 2.604, I should get approximately 6.25. A triangle has vertices -2, 1, so to the left 2 and up 1, 3, 1, so to the right 3 and up 1, and 1, 4, so up to the right 1 and up 4. Okay, we can connect the dots. So this is a right triangle, it would appear, with the right angle being over here. And I can call the height on this one, actually, I can drop down a perpendicular line here. Remember when we were talking about the base and the height? So I can call this the height, and this height here is 1, 2, 3. And this distance here is 1, 2, 3, 4, 5. So I can do 1/2 the base times the height. The base in this case is 5, and then the height is 3. Five times 3 is 15, and then half of 15 is 7.5. And since I don't have units, I would just call it units squared, and it's squared because it's area. The product, 53 times 120 is equal to 53 times 120 plus 100 plus 20. So all they've done is rewrite 120 as 100 plus 20. And they're equal because 120 is equal to 100 plus 20. Which of the following shows how to rewrite 53 times 100 plus 20? Now this is talking about the distributive property, which says you take the number on the outside and you multiply it by each of the numbers on the inside, and you keep the sign the same in between. So I have 53 times 100 plus 53 times 20. So it looks like C is the correct answer. So it says, explain how the answer to problem 17 can help us calculate 53 times 120. So I'm just going to describe it in words, and then you can write down your own answer. Basically, I might not know offhand how to do 53 times 120, but 53 times 100 is pretty easy, since you would just add 2 zeros. And 53 times 20 is pretty easy, because all I'm doing is multiplying 53 by 2 and adding a 0. So when we turn things into just having zeros, then the multiplication becomes easier. Arrange in order from least to greatest. So only one of these numbers is negative, so that'll be the least. And then comes 0. Then we have to figure out, of these numbers up here, which one is bigger, which one's smaller. Well, we have 0.5. 3 is less than half of 7, so this will be less than 0.5, and 2 is more than half of 3, so this will be greater than 0.5. So it looks like 3/7 comes next, then 0.5, and then 2/3. Chef Paul forgot to put pepper in the gumbo. If each bowl of gumbo needs 1 1/3 teaspoons of pepper, how much pepper will Chef Paul need for 6 bowls of gumbo? So I would take 1 1/3 times 6. So 1 1/3 is the same thing as 4/3 times 6 is the same thing as 6/1. Both 6 and 3 can be divided by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. And then 4 times 2 is 8. 1 times 1 is 1. But that would just mean 8. And the units then are teaspoons. So he needs 8 teaspoons of pepper for 6 bowls. If you're a visual person, you could also do it like this. So if I need 1 1/3 teaspoons of pepper, each of these represents a teaspoon. So I would say, all right, I have 1 whole and 1/3. There's 1 bowl that's done. And then the next bowl, I have 1, 2, 3. That's 1 whole and 1 extra teaspoon. That's 2 bowls done. And then I have 3/3, which is 1 whole and 1 extra. That's 3 bowls done. So for half the number of bowls I needed, I have 4. So this is 3 bowls. Need 4 teaspoons. So then I would just double them. 6 bowls. You need 8 tablespoons. Teaspoons, excuse me. So that's an alternate way to do it if you're a more visual person. Number 22, solve by inspection. So 22 minus some number gives us 10. Well, we have to take 2 off and then another 10. So it looks like n should be 12. And we can check, is 22 minus 12, is that 10? Yep. So it works out. And then d divided by 4, so a number divided by 4, that equals -8. Well, it has to be a negative number for d, because a negative divided by a positive will give me a negative. And then what number, when I divide it by 4, gives me 8? That's 32. So I'm going to guess that d is -32. So 32 divided by 4 is 8, and then -32 divided by 4 would be -8. What is the median for this set of data? Median comes from putting the numbers in order from smallest to biggest. and then finding the middle number. So the smallest is 3, then 5, then 9, then 11, then 13, and then 16. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we work our way to the middle. So 3 and 16 get knocked off together, 5 and 13 get knocked off together, and then the question is what number is directly between 9 and 11? And offhand, I know that that's going to be 10. The other way that you could do it would be 9 plus 11 divided by 2. 9 plus 11 is 20, divided by 2 is 10. Either way. Ted drove 294 miles in 7 hours. What was his average speed in miles per hour? So miles per means divide. Hour means I'm going to take the number of miles, 294, and I'm going to divide that by the number of hours, 7. How many times does 7 go into 2? It can't. How many times does 7 go into 29? It goes 4 times. 4 times 7 is 28. 28. 9 minus 28 is 1. Bring the 4 down. How many times does 7 go into 14? Twice. 2 times 7 is 14. I have no more numbers and my answer is 0. So looks like we have 42 miles per hour as his average speed. So expand means use the distributive property. So I'm going to take the 3 and multiply it by the 2x. And then keep the sign in between them. And then take the 3 and multiply it by the y. So I can do 3 times 2 is 6, x minus 3y. In 25, when we're factoring, it's like we're starting with this, and we're trying to get back to this. So we look at 18 and 27, and we say, what's the biggest common factor that those two numbers have? And they're both multiples of 9, so they both can have a 9 in them. So to get 18 with 9, it would be 9 times 2x. And to get 27, it would be 9 times 3. So now I'm basically at this step here. And now I want to go backwards and factor that 9 out, just like the 3 was out before. So it'll be 9 out front, and then once I get rid of those, it's whatever's left. 2x minus 3. The orbit of the moon is elliptical. The distance from Earth ranges from about 226,000 miles to 252,000 miles. Write the greater distance in scientific notation. So the greater distance is 252,000 miles. And to write it in scientific notation, I move the decimal point so that there's just one non-zero number to the left of it. And then I look and say, okay, I've moved the decimal point then 1, 2, 3, 4, 5 places. So times 10 to the 5th. The greater distance is about what fraction of a million miles? So, a million miles is 10 to the 6th. So 1 times 10 to the 6th. What do they want here? So if I do 252,000 divided by 1 million, basically what that means is that I'm going to take the decimal point of the 252,000, and I'm going to move it one place for every zero in the million. And a million has 6 zeros. So 1, 2, 3, 4, 5, 6. So that equals 0.252. And if I'm looking for what fraction, 0.25 is 1/4. So about 1/4 of a million miles. Classify this triangle by angles and sides. So by angles, since there's a right angle here at C, it's a right angle, or a right triangle. And then by sides, since these two sides are equal, and there's a right angle, we know that it can't be equilateral, so it has to be isosceles. Only those two sides are equal. Marion, a store owner, uses the formula C times 175 equals P to price items. C is how much she pays for the item, and P is the selling price. How much will she charge for music boxes that she purchased for $16? So I'm going to do 1.75, and the cost to her was $16, and what does that equal? Well, we can do this a couple of different ways. One way would be to just multiply the numbers straight out, but that might be kind of difficult. Or we could say 1 times 16 plus 16 times 3/4. Because 3/4 equals 0.75. So this is 1.75. 16 times 1 is 16. And then 3/4 of 16. 16 divided by 4 is 4. 4 times 3 is 12. So 16 plus 12 is $28. So she would sell it for $28. Another way that we could do it is multiplying the decimals. So we would ignore the decimal to begin with, and we would say 175 times 16. 5 times 6 is 30. 6 times 7 is 42, plus 3 is 45. 6 times 1 is 6, plus 4 is 10. And then add the 0. 1 times 5 is 5. 1 times 7 is 7. 1 times 1 is 1. Add the zeros. 10, 18, 8, and 2. And then we ignored 1, 2 decimals, so we go over 1, 2 places, and we get $28 this way as well. It's always nice to be able to check your answer using another method. The last two problems. Use this figure to find A and B. Well, this right here is something that are called vertical angles. And in vertical angles, the angles that are diagonal from each other, so 40 and A in this case, are equal. This one here and this one here would also be equal to each other, but not necessarily equal to the 40 and A. So we know from the diagram that A is 40 degrees, and that's because it is a vertical angle. And then we also know that this one right here is 90 degrees. So we have 180 degrees total for the triangle, minus 90 degrees for the right angle, minus 40 degrees for A, equals 50 degrees for B. Miles is building a right triangle shaped pen for his chickens. He has a 45-foot roll of chicken wire and plans to make the two shorter sides 12 feet and 16 feet. Will he have enough chicken wire to go all the way around? So the question is, we have 12 feet and 16 feet, and then we'll figure out what that has to be. And when we find the perimeter, we add them up, it's 45 feet or less, then he has enough. And if it's more than 45 feet, he doesn't. So, by the Pythagorean theorem says a squared plus b squared equals c squared, and question mark is c. So we have 12 squared plus 16 squared is c squared. 12 squared is 144. 16 squared is 256. $144 and 256 is 10, 10, and 4. So 400. And then to find just c, we take the square root. Well, the square root of 400 is 20. So that says that this side here is 20 feet. So now if we add all those together, 12 plus 16 plus 20, 6 and 2 is 8, and 1 and 1 and 2 is 4. So 48 feet is what he would need, and he only has 45. So no, he would need 48 feet for the pen, and he only has 45 feet. So hopefully he checked it before he started.